Hello, so in today's video, we're going to prove a trig identity. So this is an identity that you actually don't need to know, but it's quite a famous one. So it's writing sine theta in terms of half angles of tan. So the formula is sine theta equals 2 tan theta over 2 plus 1 tan square theta over 2. So again, you don't need to know this formula, but you could, I guess, be asked to prove this formula in the exam. So how to prove this one? So you want to start with your right hand side in this case. So sometimes it's easy to start with your left hand side in a proof question. Sometimes it's easy to start with your right hand side. I mean, in this question here, it's better to start with your right hand side because you can do more work with this, or it's more obvious what you should do with the right hand side or how you can proceed with the right hand side. So, okay, we're going to start with this this tan fraction here. So 2 tan theta over 2 over 1 plus tan squared. So what I'm going to do is I'm going to rewrite this as two lots of sine theta over 2 divided by cos theta over 2. And then I'm going to do a very similar thing down here. So 1 plus, we got tan squared. So tan squared is sine squared over cos squared. So sine squared theta over 2 divided by cos squared theta over 2. So now what I'm going to do is I'm going to multiply, so we've got three terms in the fraction, that term, that term, that term. I'm going to multiply those three terms by cos squared theta over 2. So what I mean is I'm going to do the top thing here, so sine theta over 2 over cos theta over 2. I'm going to times that by cos squared theta over 2. And then I'm going to divide that by 1 times cos squared theta over 2. Cos squared theta over 2. And then plus this fraction here times cos squared theta over 2. Well, that's just going to become a sine squared theta over 2. So this number there times by cos squared theta over 2, again, that would cancel out with that there. So that's why we're just left with a sine squared theta over 2 on the bottom down there. Okay, so we get that. Now we can actually cancel out one of these cos theta over 2's on the top here. So this squared one can cancel out with that there. So what we get then is we get two lots of sine theta over 2 times by cos theta over 2 divided by cos squared theta over 2 plus sine squared theta over 2. Right, so what do you notice about the bottom? Remember, sine squared plus cos squared is 1. This is just the number 1 on the bottom. So you've got sine theta over 2 times cos theta over 2. This is just the number 1. So we've got 1 on the bottom. So therefore, we're just left with two lots of sine theta over 2 times by cos theta over 2. Now, we should know because if you've seen my previous videos in the last few days on double angle formulas, what you would remember is you would remember this down here. So again, you can check out my channel, A-Level Maths UK. The double angle formula video will be in my trigonometry, A-Level trigonometry playlist, and also my A-Level pure math syllabus playlist. So remember from our double angle identities that sine 2 theta is equal to two lots of sine theta times cos theta. So that means that if you half all the angles in this identity, so half this angle there, you get sine theta, and then half the angles in the result, so half of theta times by cos of theta over 2, we get this result here. So therefore, sine theta is the same as 2 sine theta over 2 times cos theta over 2. So this is literally just sine theta. So this is actually just sine theta. And so we've proved the result that, yeah, this big fraction involving half angles with tan involved is actually just sine theta. So we've proved that formula using a little trick where we just rewrite tan as sine over cos, multiplying by this cos squared, and then basically realizing that two lots of sine theta over 2 times cos theta over 2 is the same as sine theta because of the double angle formula. We can just half the angles in the double angle formula and we can get our result. So that's how you prove that identity, this specific identity that we wanted to prove there today.